a new topic in pericyclic reactions, that is sigmatropic reactions. Sigmatropic reactions, as the name indicates, some sigma bonds are involved. Migration of sigma bonds in a pi framework is named as sigmatropic reactions. All the reactions in which migration of a sigma bond takes place through pi framework, that comes under this class of pericyclic reactions. Basically, this is a class of pericyclic reaction. It involves, as I have already told you, that pericyclic reactions are the game of p orbitals. So that is pi framework. So let's take an example in which this group, any group G, is attached to this carbon atom with a single and double bond. So this part of the example indicates a pi framework, and this indicates a sigma bond. Sigma bond. So what we will have to do is, in sigmatropic shape test, migration of this sigma bond through a pi framework. So what happens is, like, this bond shifts here and this group goes to position number 3. Naming is like wherever naming I will explain in another part of the video. Here the shifting of this group attached at position number 1 goes to position number 3. Therefore we are calling it 1,3 sigmatropic shift. The the product bond is like this bond which was single becomes double. The migration of this pi bond here and the migration of the sigma bond here will give this. Once again we can see this example in terms of, in view of the carbon and its hybridized state. Position number 1, this carbon is sp3 hybridized, and position number 3, this carbon is sp2 hybridized. But in product, the inversion of this thing takes place, that is position number 1, from where the sigma bond has migrated, the origin of the sigmatropic shift becomes sp3, and the destination where the sigma bond has reached, this destination becomes sp3. This becomes sp2, sorry, and this becomes sp3. So that is, we can define the sigmatropic reactions with the migration of a sigma bond in a pi framework, or in a view we can also see that the migration of the origin to the destination, the hybridization state changes from sp3 to sp2. Let's take another example in which there is a extended pi framework. In extended pi framework, again there is no problem. Position number 1 is that carbon which has this old sigma bond. This old sigma bond will migrate to a new position with this pi framework. Since earlier we were having this part of the example only, but now it's an extended conjugation. Therefore, the migration will take place to the last 5th orbital. Again, we can view this as conversion of an origin carbon from sp3 to the destination carbon sp2, and formation of a new sigma bond over carbon number 5. This is a new sigma bond, and this migration from old position to a new position takes place to a pi framework. Now, how to name these type of reactions? Naming of sigmatropic reaction is again very simple. As I have told you, the position from where the group has to be migrated. This group can be any. Don't go for the IUPAC that double bond should be given origin carbon to the destination carbon. Here in this example, the G group is migrating from position number 1 to position number 3. Therefore, the name of the sigmatropic reaction is 1,3 sigmatropic shift. In the similar way, in general, if we are using n number of bonds over here, the pi framework involves n number of pi doubly bonded carbon atom. For example, here we are having only 3. So 1, 2, 3. Here we can take an example of 1, 2, 3, 4, 5, 6, any to any number. Migration will always take place from position number 1, that is the origin sp3 hybridized carbon, to the last sp2 hybridized carbon, that is the nth carbon, with the formation of a new sigma bond, the breakage of the old sigma bond. This involves the migration from position number 1 to position number n. Therefore, we are calling it as 1n shift. From this example, we can clearly say that it will only have shift 1,5 shift, 1,7 shift, that is an odd number will be used. For this, we can simply write, if we have number of electrons I can say number of double bonds. Number of double bonds. If number of double bond is 1, like in this example, number of double bond is 1, so it will have a 1-3 shape. 1, 2, 3, 1-3 shape. 1-3 shape. So that type of reaction is known as, by simply seeing the number of the double bonds, we can indicate the type of shifting or the type of sigma bond. If we have the number of double bond 2 number of double bonds, 1 and 2. So 2 number of double bonds always will have a single bond. For having the conjugation, that is for the condition of the resonance, we need to have a double single framework. So for this double single framework, if there are 2 double bonds, then this example turns out to be like 1, 2, 3, 4, 5. So the shift is 1, 5 shift. If we are having number of double bonds 3, so question number 1, 2, 3, 4, 5, then a single, then a double. That means for every double bond there is an increase like an odd increase. So therefore this is going to be 1, 7 shift. Similarly, if we are having n double bonds, like in this example, if we are having n double bond, then the shift will be 1, 2 n plus 1 shift. So this is the basic naming of the sigma bonds, like from where the position number 1 is an origin. You can clearly indicate the number of double bonds will decide the type of shift. You can draw this. See? In the similar fashion, as we are having 1, 3, 1, 5, 1, 7, 1 n 2n plus 1 shift, we can also have, it is not always compulsory to have a 1 position over the first number. We can have a 3-3 sigmatropic shift also. For example, in this case, we can have a migration from these positions. This is migrated over here. So this migration takes place like the bonds will shift like this. The formation of a new sigma bond takes place over here, and the breaking of the old sigma bond takes place from position number 3. In view of hardization, we can say the older position is now the origin of the shift is having sp3 hardized carbon. This sp3 hardized carbon atom is now converted into a sp2 hardized carbon atom, whereas the destination, which was sp2 hardized, is now converted into sp3 hardized. So the concept remains the same, the migration remains the same, but now because of the position of the migration, that is because of the formation of the new sigma bond takes place between 3 and 3, we can call it as 3-3 sigmatropic shift.